A fire, a car engine, and a cell all do something similar. They oxidize carbon to release energy. All three use carbon-based molecules as fuels. Wood is cellulose, a polymer of hundreds to thousands of glucose units. Gasoline is a hydrocarbon mixture, between 4 and 12 carbons long. Foods that fuel our cells are glucose and fatty acids. Adding a little bit of energy from a match, a spark, or ATP disrupts the chemical connections between atoms in the fuel molecules. The atoms recombine with oxygen from the air, forming carbon dioxide and water. When these new chemical bonds form, energy is released, more energy than was required to break the old bonds. No matter what the fuel is, carbon oxidation produces waste products. Complete oxidation releases carbon dioxide and water. Incomplete oxidation releases other forms of carbon too, like carbon monoxide, smoke, and soot. Different ways of burning fuel can be more or less efficient, both in terms of how much of the fuel's energy is released and how much of that energy is channeled into useful work. An open fire burns so quickly that it can't take in enough oxygen, and large carbon-based molecules are released as smoke. Energy, in the form of light and heat, comes out in all directions, rapidly dissipating from the source. A high-efficiency stove has a damper to regulate oxygen flow, allowing for slower and more complete oxidation. Other structures capture heat, so the same amount of fuel can keep us warm for much longer. In an engine, sensors and injectors carefully control the mixture of fuel and oxygen, allowing for more complete oxidation. When fuel burns, an explosion of energy moves the pistons. Other moving parts channel some of this energy into the useful work of turning the wheels. Most efficient of all, the cell oxidizes the fuel from our food completely, forming carbon dioxide and water. Internal sensors control our breathing and heart rates, bringing oxygen to our cells. Networks of enzymes work with tight control. Like an assembly line, they gradually transfer the energy from carbon oxidation into ATP molecules. ATP, in turn, drives all the work of the cell. Even though a cell metabolizing glucose looks very different from an open wood fire, it's important to remember that they are both carrying out the same basic chemical reaction. They're oxidizing carbon. The difference is that the cell does it with much more control.